Okay, I wanted to make a quick little video on what we went over in class today. Happy Mole Day, by the way. And it's just going to hopefully reinforce what you picked up in class today. So thank you, Caleb, for the suggestion. I'm going to do number 5 for the formula mass, or what we call the molar mass also, because I want to make sure that you understand how to distribute anything outside of parentheses. So we have our NH4SO4 here. So there's a couple of ways that you could do it, and you could add up what's within the parentheses. So in this case you'd have nitrogen, which if you look on the periodic table is 14. And then you would add 4 hydrogen. Well, each of those hydrogen are 1.01. So 4 times 1.01 would give me 4.04. And then you would want to multiply that by 2. So in this case we have 1804 times 2. So we would have 3608 for what's in the parentheses there. Now we're not done. We need to add the sulfur. So we'd have plus sulfur, which is 32. Let's go to the hundredths here. So 32.07. And then we have the 4 oxygen, which is a little hard to see because I obscured it with some of the black ink there, but it's SO4. So we have 16 times 4, which is 64. Alright, then you would add that up. So 36 and 32 and 64. And we get 13.15. Alright, I believe my math is correct there. So it's 132.15. And that would be our molar mass. Now, that's a naked number. We never want to have naked numbers. Dress them up with units. So I would put grams per mole. Now remember, that can also be written, since it is an equality, as 1 mole is equivalent to 132.15 grams. Alright, it just depends on which way we want to have it regarding what we are trying to obtain. So if we're trying to get moles, we want to have this one because moles are on top. If we're trying to get grams, we would want to have 132.15 grams on top, 1 mole on the bottom. And that would allow us to get grams. Alright, so let's take a look at one where we're actually converting. So in this case we have, we'll do number 9 here. Alright, so we have how many moles are in 68 grams of copper 2 hydroxide. And it gives us the formula there, CuOH2. So what we want to do first is get the molar mass. I commonly abbreviate it as MM. Same thing as formula mass. And I will take 1 copper and I will look that up on the periodic table. I will find that it's 63.55 for the average atomic mass. Now the OH Couple of ways I could do that. Again, add up with what's in the parentheses and multiply by 2, or distribute. So I have two oxygen. Each of them are at 16. So that's going to give me 32. And then I also have 2 hydrogen, each at 1.01. That's going to give me 1.02. Alright, and when I add that up, I get 66.57. That doesn't look right. Okay, I can see why. Alright, so let's try that again. That would be 356 and 96.57 grams per mole. Alright, so we got the molar mass there. We're good with that. We want to write down what our known is, as we always do. And that would be our CuOH2, our copper 2, cupric hydroxide, 68 grams. And now, what's it asking for? It's asking me for moles. So I want to have moles on top. So I'm going to put 1 mole on top here and put my grams on the bottom. Alright, my grams cancel out, and I am left with moles. And when I do the calculation here, I have 68 divided by my 96.57, and I end up with 0.70 moles of copper 2 hydroxide. So hopefully that clarifies it somewhat for you, if not entirely. Again, you're going to get it by doing them, so please do them. Check the answers in the back. If you have any questions, please let me know. All right, thank you.